Welcome back to another video. So today I'll be solving the rest of the specimen paper. Last video I've solved up to question number 18. Today I'll be starting off from question number 19. Question 19. Samples of magnesium carbonate are placed in crucibles R and S. The samples in crucible R is heated until no further loss in mass, and then allowed to cool. The sample in S is left unheated. So we have magnesium carbonate. In R, we are heating it until there is no further loss in mass. So we know thermal decomposition of magnesium carbonate will occur when we heat it. So this will form magnesium oxide plus carbon dioxide gas. Then the other sample, which is S, this is left unheated. So nothing can be observed so far. Then dilute hydrochloric acid is then added to both crucibles. So we have this thing, and then we add HCl to magnesium oxide and carbon dioxide, and carbon dioxide will not react with HCl, so we can ignore that. So magnesium oxide will react with HCl to form magnesium chloride and H2O. I'm not balancing the equation right now just because we do not need the balancing for the observations. Then if we add hydrochloric acid to magnesium carbonate, because the one which is left unheated, which is in crucible S, this is for our R. For S it is unheated, so it stays as magnesium carbonate. So when we add HCl to magnesium carbonate, we know carbonate plus acid will form magnesium chloride plus carbon dioxide plus water. Now they have asked us, on adding dilute HCl, which observations are correct. So for magnesium carbonate, we can see carbon dioxide, which is a gas. So for S it has to be gas produced, so these two options can be ruled out. And for R, there is no gas produced, because as you can see, magnesium chloride and HCl, this is for R, we cannot find any kind of gas over here, so no gas produced. So our answer shall be C. Question 20. When concentrated sulfuric acid reacts with sodium iodide, the products include sulfur, iodine, hydrogen sulfide, and sulfur dioxide gas. Yes, we know this equation. So which statement is correct? Hydrogen sulfide is the product of a reduction reaction. So let's just first write down the whole equation. So concentrated sulfuric acid, so H2SO4 reacts with sodium iodide. So we know at first these will form NaHSO4 plus HI. Now this HI, which is produced in this reaction, will further react with sulfuric acid, and this will produce many different kind of products. I'm not showing all the equations because there are a series of equations which needs to be balanced out, so I'll be showing the final balanced equation for this reaction. So we know the products which will be formed in this reaction will be iodine plus sulfur dioxide plus sulfur plus H2S plus water. If you need to balance it, this will be 3 moles of sulfuric acid, 16 moles of HI, 8 moles of I2, and 10 moles of water. This can be done, the whole step. I've basically written down the whole equation in one single step, which is basically the overall equation, because we do not need all the other steps. We can just work out the oxidation numbers from this balanced state. You do not even have to balance the equation because balancing is not required for this question, so just writing down the product will be enough. So the question says which statement is correct. It says hydrogen sulfide is produced in a reduction reaction. So let's find out the oxidation state of sulfur. So hydrogen, we know +1, so +2, because 2 hydrogen plus S shall be 0, so S shall be -2. So over here sulfur, the oxidation state is -2. For H2SO4, it is 2H plus, so 2H is basically 2 plus S minus 8, because 4 oxygen, so equals to 0. So S, this will give us -6, it goes to that side, so it shall be +6. So over here we can see the oxidation state of sulfur is +6 on the reactants and -2. So this has been reduced because the oxidation number decreases. So our statement 1, which says hydrogen sulfide is produced from a reduction reaction, that is correct. So A is our correct response. So now let's go to the next question, which is question number 21. A solution of sodium hydroxide reacts with 3 moles of chlorine under certain conditions. The reaction produces 5 mole of sodium chloride and 1 mole of X, the only other chlorine containing product. What shall be the formula of compound X? Okay, so now they have already given us sodium hydroxide reacts with 3 moles of chlorine. So this is chlorine, 3 moles of chlorine they have already given us. The reaction produces 5 moles of sodium chloride. Now 5 moles of NaCl is produced and 1 mole of X. So we do not know what X is, so let's leave it a blank. Okay, now we have to balance this equation. So over here we can see that there are 5 moles of Na. Over here we have just 1 mole of Na. But over here we have 6 moles of chlorine, because if we multiply 3 times 2, there are 6 moles of chlorine. That means there shall be only 1 other moles of chlorine on the other side. Also in our options we can see that all of them has just 1 mole of chlorine. So we can quite understand that this has to be only just 1 mole of chlorine. Also all the option has sodium in them. Okay, so these also need to have sodium. So NaCl needs to be common and some kind of oxygen need to be there. We don't know the number of oxygen which is produced, so we have to somehow balance this equation to find the number of oxygen here. Okay, so over here let's balance the other side of the equation. We have 6 moles of sodium on the product side. Here 5, here is 1, so it's 6. So we can balance it by 6 NaOH. So over here we also have 6 moles of chlorine. Chlorines are balanced on both sides because both side reactants and products has 6 moles of chlorine. Now we need to balance the OHs. So we have 6 O's and 6 H on the product side, on the reactant side, and over here we just have 1 O so far. So we can balance this the H2O. We can balance the O and H's on the product side by adding water. So there's 6 H's, so we can just add 3 moles of water, because that will give us 3 times 2 will give us 6 moles of H. So 6 H is there, but over here we have just 3 moles of oxygen. Okay, total we need 6 moles of oxygen. So 3 plus we have over here 1, but if we can add 3 over here, then this will give us total of 3 plus 3, 6 moles of oxygen. Okay, so this is the way we can solve this question. So our answer shall be C. So once again, what you need to take into account is that the product side must have NaCl, because all the NaCls are there in our options, and we just have to find the number of oxygen by balancing the equation. So by balancing the equation, since we cannot add H in any other way in the equation, we just have to add water. So by adding water, we cannot just add H in this compound, in this chlorine containing compound, because this has NaCl and O. It does not have any H. So we cannot just add any kind of H in this compound. So we can get H by adding water. Over here we have 6 H's. We get 6 H's on both sides. We have 3 moles of oxygen left. So we need 3 more oxygen in order to balance the equation on both sides. So we have to have NaClO3 in order to make the equation balanced. Okay, so in this way we can solve this question. Okay, question 22. Redox reactions are common in chemistry of group 17 elements. Which statement is correct? The first option says Br minus ions will reduce Cl2 not I2. So let's write down an equation to understand this. So for example, we can just write a very simple equation. So let's rub these things off. Okay, so for example, we have NaBr reacting with Cl2, for example, and this will form NaCl plus Br2. Over here, an important thing which you have to notice is it is said that Br minus ion. So Br minus ion is basically this one, because this has a charge of -1, this is +1. So Br minus ion over here is being oxidized to Br2, and this is actually reducing the Cl2 to Cl minus. Okay, so this is getting reduced. So Br minus ion is actually reducing Cl2 over here, so this is correct. Now if we react NaBr plus I2, this won't produce any kind of reaction, it will remain the same. This is because Br minus ion cannot reduce I2. Okay, this is because, as we know, for halogens, for halide ions I shall say, if we from chloride, bromide, iodide, as we go down, the reducing ability increases. Okay, so reducing ability of halide ions increases as we go down the group. Okay, so as a result, I minus shall have a higher reducing ability than Br minus. So option A is correct, because Br minus can reduce Cl2 but it cannot reduce I2. Okay, next option says Cl2 will oxidize Br minus ions but not I minus. No, it cannot oxidize either of them, so that's wrong. F2 is the weakest oxidizing agent out of these things. No, this is wrong, because they're talking about oxidizing agent, they're talking about halogens here. So as for halogens, you know, I2 must be the weakest oxidizing agent and F2 needs to be the strongest oxidizing agent. Option D says I minus ions are the weakest reducing agents out of these things. No, this has to be strongest. So all the other options are wrong. So let's move on to our next question. Question number 23, it says, which statement describes the trend of period tree between every pair of adjacent elements from sodium to chlorine? So as we move from sodium to chlorine in the period tree, we know that the atomic radius decreases. So this is true, so the first option is correct. Let's move on to the next. Let's see the next options. It says the first ionization energy decreases. No, we know it increases. The melting point decreases. No, there is a variation in the trend of melting point, so there is no fixed increase or decrease, so that's wrong. The electrical conductivity increases. That's wrong, because electrical conductivity increases and then there is no electrical conductivity of the non-metals, so that is obviously wrong. Okay, so next question, question number 24, it says nitrogen forms pollutant oxide Y in car engine. Okay, further oxidation of Y to Z occurs in the atmosphere. In the further oxidation, 1 mole of Y reacts with 0.5 moles of gaseous oxygen molecules. Which statement is correct? So the second line says that further oxidation, 1 mole of Y reacts with 0.5 moles of gaseous oxygen in the atmosphere. So we know NO is produced in the car engines. We also know the equation catalytic converter, where it converts NO and carbon monoxide into carbon dioxide plus nitrogen. So we're not dealing with that over here, but just for the information. So NO is produced. So NO reacts with half moles of oxygen at the atmosphere, we know, to form NO2. So this is 1 mole and this is 0.5 mole of gaseous oxygen it is reacting with. So this is our compound Y, this will be our compound Z. So which statement is correct? Compound Z does not react further in the atmosphere. No, it does react further, because NO2 can react with water to form HNO3, which is nitric acid, which can fall down as acid rain. It also reacts with oxygen over here to form nitric acid. So option A is wrong. Option B says molecule of Y contains 15 electrons. So molecule Y, we know this is NO. So if we calculate the number of electrons, N has 7 electrons, because the proton number is equal to the electron number, and oxygen has 8 electrons, so this will give us a total of 15 electrons. So option B is correct. Option C says the oxidation number of nitrogen increases by 1 from Y to Z. So let's check the oxidation number. So NO over here, N minus 2 is 0, so N is plus 2. So over here we have plus 2 oxidation state, N minus 4 equals to 0 for NO2. So N is plus 4, so over here it becomes plus 4. It says oxidation number increases by 1. No, this is wrong, it shall be increases by 2. Y is a non-polar molecule. This is wrong, because Y is an oxide. Oxides are not non-polar. N2 is non-polar, but NO is not non-polar, because there is a difference in electronegativity between nitrogen and oxygen, so it's not non-polar. Question number 25. Structural and stereoisomerism should be considered when answering this question. Each of the following carbonyl compounds is reacted with sodium borohydride or NaBH4. The product of each reaction is heated with Al2O3 at 600 degrees Celsius to give either an isomer or a mixture of isomers. Which carbonyl compound will produce the most amount of isomers? Okay, let's take the first one. For example, it says butanol. So butanol has meth-prop-but, so it has 4 carbon over here. So this is an aldehyde. So this is the structure of butanol. So when it reacts with NaBH4, this butanol will be reduced to alcohol. So which is basically this will be reduced to primary alcohol. So you can just do it like this. So after reacting with NaBH4, this will form this primary alcohol. This is then heated with Al2O3 at 600 degrees Celsius. So we know Al2O3 reduces this alcohol or causes an elimination reaction to occur, making this alcohol alkene. Okay, so whenever alkene is formed, this OH is gone and a double bond is formed between the 2 carbons. So over here a double bond is formed. So this is the alkene which is produced. Since the H is, this is a primary alcohol, this will only form 1 alkene. Okay, and this carbon is bonded with 2 hydrogens and 1 hydrogen. Since this double bonded carbon is bonded with 2 of the same type of hydrogen, this will not exhibit any form of cis-trans isomerism. Okay, so this will only form 1 product and there are no isomers. Okay, so 1 shall be wrong. Next, let's see butanon. So butanon is a ketone. So once again 4 carbons and butanon is a ketone, so there will be a double bonded O with a carbon. So once again, once we reduce this will form a secondary alcohol. So this is the alcohol which will be produced, and now whenever it will be heated with Al2O3, this will form an alkene. So C double bond C, and this is the first alkene which can be formed because the OH is over here with the second carbon. So the first alkene, this can form bond between the first and the second carbon. So this will be the one of the products. And the second thing which can happen is that a double bond will be formed between the second and third carbon. So or let's say, so C double bond C. So this is the other product which can be formed. Now as you can see, this will not form any cis-trans isomerism because this has 2 hydrogen, 1 carbon bonded with 2 hydrogens, so no cis-trans here. But however, if you take a look at this compound, this has carbon, this double bonded carbon bonded with 2 different types of atoms or groups of atoms, you can say. So as a result, this will show cis-trans isomerism. Okay, so this will form cis-trans isomers. So total there shall be 3 isomers over here. This is the first, this is the second, one is the cis and one is the trans. So total there are 3 isomers. So this will have 3 isomers. So let's take that into account. Let's go for pentan 3 on. So this will have 5 carbon. So it says 3 on, so the third carbon shall have the O over here. So now when it will be converted to alcohol, this will be an OH will be added over here. So now once this is converted to alkene by Al2O3 and 600 degrees Celsius temperature, this can form double bond in 2 places. So first double bond can be formed over here, or a double bond may be formed over here. But one thing, if you notice, the double bonded carbon will always be 1, 2, 3, 4, 5. So it will always form within the second one. So it will always form pent 2 in, because if the first double bond, if we consider this double bond forming over here, then we have to start counting from the left hand side. So 1, 2 and 3. Now if we consider from the left hand side, if we consider this double bond over here, then we have to count from the right hand side. So 1, 2, 3. So it is always forming between the second and the third carbon. So it will always form pen 2 in. So as a result, this will only form 1 isomer. Also, if we take a look at pen 2 in, which is basically this compound. So this will show cis trans isomerism because this has carbon bonded with 2 hydrogen and 1 methyl group and 1 ethyl group. So it will show cis trans isomers, but total we just get 2 isomers over here, which is obviously less than our butanol. So 2 isomers. The last one we have propanone, which is 3 carbon aldehyde. So if we convert this will just form a primary alcohol once again. So once we convert it into ketone, this will just form one isomer, just like our first option. So it will just form one product. So this is wrong. So our answer is B, because that shows the most amount of isomers. Okay, question number 26. The drug cortisone has the formula shown. In addition to the chiral centers, which is marked over here by the asterisk, how many other chiral centers are present in the cortisone molecule? Okay, so let's find out the other chiral centers. So over here we can see one chiral center, another chiral center other than the ones which they've already marked. Over here we have another chiral center. Here we have another chiral center. So we cannot see any other chiral center over here. Here there is a double bond, double bond, double bond. There is 2 hydrogen over here, double bond, 2 hydrogens, 2 hydrogens. These ones are already marked. So 2 hydrogens, 2 hydrogens. So no other chiral centers. So we have 1, 2, and 3 other additional chiral centers. So D is our correct response. Now question number 27. An alkene is reacted with acidified potassium permanganate ions MnO4-. The organic product has a relative molecular mass greater by 34. Which conditions are required? So we know whenever an alkene can react with 2 types, there can be oxidized in 2 ways. One is the hot concentrated KMnO4 and another is cold dilute MnO4- ions. Okay, so the A and D is already wrong because they won't do anything. They won't even oxidize the alkene properly. So option B and D. So we know when hot concentrated MnO4 is used, it forms different types of products based on the number of hydrogen carbon is bonded with, and when cold dilute MnO4 is used, it will form a diol. Now let's calculate. Over here they have said an important point is that the molecular mass is greater by 34, greater than the alkene by 34. So if we consider diol is basically 2 OH groups. So 2 OH group will have an MR of 2 oxygen and 2 hydrogen. So 16 times 2 plus 2 will give us 34. So whenever diols are produced, the mass or MR will increase by 34. Therefore, the correct response to this question is B. Question number 28. The diagram shows a short length of addition polymer chain. The polymer has a relative molecular mass of approximately 10,000. Approximately how many monomer units are joined together in each polymer molecule? Okay, so over here we can simply identify this is one monomer unit because these are the repeat units. So this has to be our one repeat unit over here. So our monomer shall be carbon double bonded with carbon and 4 hydrogens over here. Okay, so if we calculate the mass of this, which is basically 12 times 2 plus 4, if we calculate it, this will give us 28. So the number of monomer units is basically 10,000 divided by 28, which will give us 357, which is approximately 360. So B is our correct response. The next question is, lactite is an intermediate in the manufacture of synthetic fiber. Which compound on heating with acid catalyst can produce lactite? So we know when esters are heated, so we can just understand from the structure that this has to be an ester because there is a carbon oxygen bond, single bond, and there is a carbon oxygen double bond. So whenever these esters are reacted with an acid catalyst, we know these bond between the carbon and the single bonded oxygen breaks down. So you can break down the bonds over here, here, and here. Okay, so this will lead us to a compound. Over here we have C. We have a CH3 over here. We have another C which is bonded to this oxygen. So if we simplify this structure, we will get there are 3 carbons over here. One is a CH3 over here. So CH3. 1 carbon is bonded with an oxygen, the hydrogen, and this is double bonded with an oxygen. which is, so whenever this carbon is double bonded with oxygen, this has to be a part of a carboxylic acid, and single bonded O, this has to be a part of an alcohol, because we know this part of an ester which is single bonded with O comes from the alcohol part, and this double bonded O comes from the carboxylic part, so C double bond OH. So we basically have to identify the which compound on heating with acid catalyst will produce this lactite. So this is the compound which needs to be burned, which needs to be heated with acid catalyst. So if you name this compound 1, 2, 3, sorry, carboxylic acid has the highest priority, so we need to start counting from this side. 1, 2, 3. So meth, eth, prop. So this is propanoic acid, and since the OH group is on the second carbon, so it shall be 2-hydroxy. So 2-hydroxy propanoic acid shall be the name, so which is shown in option C. So C is our correct response. Question 30. Diols in which both hydroxy groups are bonded to the same carbon atom spontaneously eliminate a molecule of water to produce a carbonyl compound. Okay, so this is a very important information which they have already provided us, so let's highlight it. Next, they say which compound is hydrolyzed to form a product that gives a positive result with 2,4-dinitrophenyl hydrazine and not Fehling's reagent. So 2,4-dinitrophenyl hydrazine, we know this will show a positive result with only with carbonyl compounds. Okay, with basically aldehydes and ketones. Okay, so any types of carbonyl compounds will show a positive result with 2,4-dinitrophenyl hydrazine. But it says it does not react with Fehling's reagent, so this has to be a ketone, because ketone does not react with Fehling's reagent, aldehydes do. So this has to be a ketone. Okay, so very important thing. So we have to just find ketones over here. So first option they have given us is 1,1-bromopropane. So propane shall have 3 carbon atoms, and bromo means 2 bromines. So this is our first compound. So we know they have given us this will spontaneously remove water, so to form a carbonyl compound. So these bromines are removed, and so at first whenever they are hydrolyzed, this will form OH and OH. These bromines will get replaced by OH once the BRs are hydrolyzed. Now this OH is formed. These two OH they have given us when both hydroxy groups are bonded to same carbon atom, they spontaneously eliminate water to produce a carbonyl compound. So that is given to us. So these OH and these OH will be removed to form a carbonyl compound. So if we remove these two OHs, this will form a carbonyl compound which will be an aldehyde. But we over here need a ketone, so option A shall be wrong, because this produces an aldehyde. So option B, it says 1,2-bromopropane. So once again 3 carbon. So 1,2 means 1, and carbon 1 and carbon 2 shall contain this bromine. Now whenever this will be hydrolyzed, these bromines will be replaced by OHs. Now since both this OH is not bonded to the same carbon atom, so they will spontaneously eliminate water. The same for 1,3-dibromopropane, the OH will be on different carbons, so there will be the first carbon and the third carbon, so they will not spontaneously eliminate water. Now for option D, let's come to option D. It says 2,2-dibromopropane. So once again 3 carbons, so bromine. So whenever this will be hydrolyzed, these bromines will be replaced by OH. Now they have given us these two OH will spontaneously remove water to form a carbonyl compound. So over here whenever water will be removed, since this is from the second carbon, so this will form a ketone. Okay, because we cannot form an aldehyde in the second carbon. So D shall be a correct response. Question number 31. So it says that X and Y are reagents that require to convert 1-bromopropane into butanoic acid by the following reaction. What are the correct identities of X and Y? So X, this Br is being converted to Cn, which is a nitrile. So whenever halogenal alkanes are converted to nitriles, this has to be KCN or NaCN, sodium cyanide or potassium cyanide in ethanol, okay, or ethanolic. So B and C, option A and D can be can be removed. Now this Y needs to be hydrolysis. So CN is hydrolyzed to form carboxylic acid, so it can be acid hydrolysis or alkali hydrolysis. Now this has to be acid hydrolysis because we can see that this is carboxylic acid remains. Okay, if this was alkali hydrolysis, if we gave NaOH, then this acid would further react with NaOH to form salt of carboxylic acid. Okay, so instead of COOH, this would have been, there should have been an Na over here, but we are not getting any salt of carboxylic acid, so as a result this has to be acid hydrolysis. Okay, in that way this acid, this carboxylic acid won't react with the acid, so option C is a correct response because this has to be HCl, not sodium hydroxide. Question number 32. Q is a compound with the molecular formula C4H10O. Q can be oxidized with acidified potassium dichromate. Q cannot be made by reducing carboxylic acid with lithium aluminium hydride. So this just proves us that it can be oxidized by acidified potassium dichromate. However, it cannot be made by reducing carboxylic acid. So we know whenever we reduce carboxylic acid, this will form a primary alcohol. So since Q cannot be formed by reducing this carboxylic acid, this means this cannot be a primary alcohol. Now option B, C, D all shows a primary alcohol. So only option A does not show a primary alcohol. So it has to be option A. How do you know this is an alcohol? Because there is a 1O group, so 1O is only an alcohol. So option A needs to be correct because option A does not show a primary alcohol. All other options shows a primary alcohol. Question number 33. A sample of 2.3 grams of ethanol is mixed with excess aqueous acidified potassium dichromate. The reaction mixture is then boiled under reflux for 1 hour. The required organic product is then collected by distillation. The yield of the product is 60%. Which mass of product is collected? So let's write our equation. They have said that ethanol, which is C2H5OH, is reacted with acidified potassium dichromate, so not manganese, it's dichromate, so K2Cr2O7. Okay, so this is acidified. So we know this is an oxidizing agent, so this will oxidize this into carboxylic acid, which is basically ethanoic acid. So over here we have 2.30 grams of alcohol. So let's find out the moles of alcohol. So moles of ethanol is basically 2.30 divided by the MR. So if we do this will get 0.05 moles of ethanol. So moles of ethanoic acid shall also be 0.05 because 1:1 ratio, because 1 ethanol will produce 1 ethanoic acid. Okay, so now it says that the yield is 60%. So let's do a 60% of 0.05. So 60% of 0.05 will give us 0.03 moles. Now let's calculate the mass of ethanoic acid. So mass of CH3COOH is basically moles times MR, which is 0.03. If we multiply it by the MR of ethanoic acid, which is basically we have 12 plus 3 plus 12 plus 16 times 2 plus 1. So if we do this, we are going to get 1.80 grams, which is our option C. Okay, now next question. Compound R gives a positive test with aqueous alkaline iodine. This is the iodoform reaction. That means this has to have CH3CHOH or CH3COH or CH3CO, sorry. Okay, so this is for alcohol, this is for aldehydes, this is for ketones. Okay, so these groups must be present. So compound R does not display stereoisomerism, so this is another important thing which they have mentioned. So at first let's look for these groups in this compound. The first one, CH3CO is present, so yeah, we can consider this. Option B, no CH3OH or CH3, anything like this, anything of these three is not present. Also in option C we have CH3CO, so we can consider option C. Option D does not have any CH3 or any of these things, so option D is already eliminated. So now let's just compare between these two options, option A and option C. So let's take a look at option A. In option A, we have firstly they have mentioned that they do not display stereoisomerism, so A should not display stereoisomerism for it to be the correct response. So CH3, C double bond O, CH2, CH2. I'm not writing the hydrogens because they're the same. So over here, this won't show stereoisomerism because we cannot find any chiral centers over here, no chiral centers, so it does not display stereoisomerism. So automatically A shall be the correct response, but let's see why C is not the correct response. Now if you take a look at C, there is CH3, CH3, CO, which is a ketone, CHOH, CH3. Now we can see that this carbon is a chiral center. Okay, this is a chiral center because this is bonded with one hydrogen, one OH, one of these things, and one of CH3. So this is a chiral center, so this will exhibit stereoisomerism. Okay, so as a result, option C is wrong, so A is the correct response. Question number 35. Citral is found in lemongrass oil. It can react to give compound W. Okay, so which compound, what could compound W be? So at first they have given an excess of hydrogen in presence of nickel catalyst. So we know this will convert alkene to alkane. So this double bond will basically get converted to alkane. We do not have to show any other hydrogen because this is the skeletal formula. We do not show any hydrogen. So this double bond will simply get converted into a single bond. No need to show anything else. Just two hydrogen will be added, but then it do not need to be shown because this is the skeletal formula. Then this V is heated with hot concentrated acidified manganate and heated under reflux. So we know this CHO will now get oxidized. So this will get oxidized to carboxylic acid because we know the aldehydes are oxidized to carboxylic acids. Okay, so now let's take a look at the options. Which option gives us this bond? Yep, but here this is not oxidized, so A is wrong. Yep, this shows a single bond and this is oxidized, so option B is correct. These options are not correct. We can just understand by seeing them. Okay, question number 36. P and Q are alkenes. They are geometric isomers of each other. Which statements is correct? So they are geometric isomers. This means that they are cis-trans isomerism. Okay, which is basically occurs due to double bonded carbons. Okay, so P and Q give different products. We all consider acidified potassium permanganate. This is wrong because they're literally same type of alkenes. So they won't give say different products. They will give same products. Okay, because they're just stereoisomers. They're not even structural isomers here. Okay, so then option B says P and Q have different empirical formula. No, they have the same empirical formula. For example, we can just consider this simple compound over here to make things more clear. So P and Q, so one we can say this is P, and Q we can say this hydrogen is now above, this OH is like this. So one is cis and one is trans. So this is our cis and this is our trans isomer. So they both are literally have the same molecular formula, same empirical formula. So they should not have same different empirical formula. Obviously they have the same functional group. Over here we can see they have the same alkene group, same alcohol group. Any kind of functional group they have, they must have the same functional group because they are geometric isomers. P and Q have different skeletal formulas. Yeah, this is correct. This is because, once again, let's take a look at these two skeletal formulas. Over here we have two carbon, so two carbon 1 and 2. Over here we have P skeletal formula will be something like this because they have OH group, so this shall be P. If you draw the skeletal formula of Q, this shall be 2 carbon, OH at the bottom and OH at the top. So we know we can see that these two skeletal formulas are different, so they must have different skeletal formula. Okay, so option D is correct. Now question number 37. The following statements about the reaction of sodium hydroxide aqueous with 3-chloroalkanes are shown. Which statement is correct? So sodium hydroxide will react with these chloroalkanes. So we know this OH will just replace this Cl because this is sodium hydroxide aqueous, not ethanolic. So this OH will get, this Cl will get replaced by OH basically. So let's take a look at the statement. CH3 2 CH2Cl, which is basically this one with NaOH will react by SN2 mechanism. Yes, this is correct, because we know these are the primary halogenoalkanes react by SN2 mechanism. Okay, whereas only tertiary halogenoalkanes react by SN1 mechanism. Secondary can react by both. So secondary can react by both mechanisms, tertiary by SN1, primary by SN2. Since this is primary halogenoalkane, so it reacts with SN2 mechanism. Okay, now let's move on to the next question, question number 38. For which mixture is the observation described correctly? Okay, the first one says pentanol plus fillings. So pentanol, this is an aldehyde. So whenever aldehyde reacts with fillings reagent, we know an orange PPT is formed. Okay, so the observation says blue solution changes to orange PPT, which is correct. So A is a correct response. Question number 39. Which statement is correct? C3H7COOH can be used to form propyl propanoid in a single reaction. So propyl propanoid, we know this is an ester. So this is a carboxylic acid. Okay, this has 4 carbons, so this is butanoic acid. Okay, so butanoic acid, it says propyl propanoid. So butanoic acid, whenever, even if you react it by propanol, this will form propyl butanoid. Okay, propyl butanoid. So we know esters can react with alcohol in presence of acid catalyst to form carboxylic acid can react with alcohol in presence of sulfuric acid catalyst to form esters, but over here, even if we consider this to be a single reaction, this has to form a butanoid, not propanoid, because this is butanoic acid. So butanoic acid, the name shall be butanoid, not propanoid. So option A is wrong. Option B says the empirical formula of C3H7COOH is same as the molecular formula. So let's write down the empirical formula. Let's also write down the molecular formula. We have 4 carbon, 8 hydrogen and 2 oxygen. So empirical formula shall be C2H4O. So this is not the same as the molecular formula. This is the molecular formula. This is the empirical formula. They are not the same. So option B is wrong. Each C3H7OH and C3H7COOH react separately with sodium borohydride. NaBH4, no, they do not react with sodium borohydride, so that's wrong. So option D says C3H7OH and C3H7COOH react separately with sodium metal. This is true. Alcohol reacts with sodium metal to form metal alkoxide, and hydrogen gas over here reacts like acid. Okay, so acid plus metal will form salt and hydrogen gas. So over here this will form, this H will be replaced by Na, and in carboxylic acid it also reacts differently because this is acid, and this will react with sodium hydroxide. Over here Na will be formed, but these are two different reactions. They're not the same because alcohol and acids are not the same. Alcohols and carboxylic acid are not the same, so they will react separately with sodium metal. So option D is correct. Okay, question number 40, finally our last question. It says compound X consists of carbon, hydrogen and oxygen only. It has only one functional group. It says what can be deduced about X. So this is our X. So over here we have a peak at around 3000. We know this kind of peak, whenever we see this kind of peak in question, then this is supposed to be a carboxylic acid. But let's confirm using the table which they have given us. We have seen this OH carboxyl is given as 2500 to 3000. This is at 3000, so this has to be a carboxylic acid. It cannot be a hydroxy because it is given 3200 to 3650, which is around here, somewhere here the range shall be. There is no peak over here, so this cannot be hydroxy. So it cannot be an alcohol, it cannot be an aldehyde or ketone, because you can see the ranges are much lower. So this cannot be an aldehyde or ketone. We cannot confirm it. And also after 1500 it is the fingerprint region. And X is carboxylic acid. We know this is correct because we can just understand from the question. It's not an alkene, so C is our correct response. So thanks for watching.